Chittagong Higher Maths 2017 question number 5. Now in question number 5 we're given the points P, which is 8, 3, Q, 3, 8 and R, minus 2, 3. These are the three vertices of a triangle. S and T are the middle points of the sides PQ and PR respectively. In part A, we have to find the slope of QR. Now to do this, it helps if we draw a diagram. So let's mark in the points P, Q and R and draw the triangle. Now, to work out the gradient of QR, we use the gradient formula. This is the gradient equals y2 minus y1 all over x2 minus x1. Now for Q, x1 is 3 and y1 is 8. For R, x2 is minus 2 and y2 is 3. So the gradient of QR is 3 minus 8 over minus 2 minus 3, which is equal to minus 5 over minus 5, and so the gradient of QR is 1. Now for part B, we want to show that the triangle PQR is an isosceles triangle and its area is 25 square units. So we want to work out the lengths of the sides RQ and QP. So to work out the length of RQ, we use the length formula, which is the length equals the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Now for R, x1 is minus 2 and y1 is 3. For Q, x2 is 3 and y2 is 8. So the length of RQ is equal to the square root of 3 take away minus 2 all squared plus 8 take away 3 all squared, which is equal to the square root of 5 squared plus 5 squared, or the square root of 25 plus 25, and so RQ is equal to the square root of 50. Now for the length of PQ we have, for P, x1 is equal to 8 and y1 is equal to 3. For Q, x2 is equal to 3 and y2 is equal to 8. So the length of PQ is equal to the square root of 3 take away 8 all squared plus 8 take away 3 all squared, which is equal to the square root of minus 5 squared plus 5 squared, which is equal to the square root of 25 plus 25, so PQ is equal to the square root of 50. Now PQ is equal to the square root of 50, and RQ is also equal to the square root of 50, so PQ equals RQ, and the triangle is isosceles. Now we want to work out the area of the triangle, but first let's work out the gradient of PQ. Now the gradient of PQ is 3 minus 8 over 8 minus 3, which is minus 5 over 5, which is minus 1. So the gradient of QR times the gradient of PQ is 1 times minus 1, which is equal to minus 1. Now this tells us that RQ and QP are perpendicular to each other. In other words, the angle PQR is equal to 90 degrees. Now that means to work out the area of the triangle, we can take the base as RQ and the height as QP. And the area of a triangle is half times the base times the height. So in this case, the area of triangle PQR is equal to a half times root 50 times root 50, which is a half of 50, and so the area of the triangle PQR is 25 square units. Now in part C we want to prove, with the help of vectors, that the line ST is parallel to the line QR, and ST is half the length of QR. Now to solve this, it helps if we draw a diagram. Now, S and T are the midpoints of PQ and PR. Now, In vectors, going from Q to R is the same as going from Q to P and then P to R. So we have QR equals QP plus PR. Now also, we have the vector SP is half the vector QP. And also the vector PT is half the vector PR. But going from S to T is the same as going from S to P and then P to T. So the vector ST is equal to the vector SP plus the vector PT. Now from this we can say the vector ST is equal to half the vector QR plus a half the vector PR. In other words, ST is equal to half the vectors PQ plus PR. So the vector ST is equal to half the vector QR. Now if one vector is a multiple of the other vector, they're parallel. So that tells us the line ST is parallel to the line QR. And also, because one vector is half the length of the other, we have the length ST is equal to half the length QR as required.